I'll be the MC for today. Thank you all for being here. We're really excited to have everybody here for AmpCamp. Before we start, I'd just like to make a few announcements. So first, we have Wi-Fi here. The username is AMP, the password is CAMP, and the Wi-Fi name is International House. The other thing I want to mention is that for your exercises this afternoon and for tomorrow, you're going to be using content on a USB key that was distributed to you when you got here, hopefully. So if you don't have one, you should go up front at some point and get one. If you do have one, I think there was a note associated with that USB key, but I just want to reiterate that you should, for best performance, you want to take the content of that USB key and copy it to your local hard drive. It's about 2 gigs, so you want to start now. It'll take 20 minutes, half an hour, depending on your machine. And if everyone tries to do this right when the exercises start, that'll be unfortunate. So please do it now while you're watching the talks. Just let your computer transfer the data. 2 other comments. So there's a small number of people who were given defective USB keys. And just to give you, to show you what the different ones look like. So on the left, what's going on here? All right, good. So on the left, you see a USB key that looks correct. It, again, should be about 2 gigs, and it should have, 6 directories and a README. On the right is a USB key for some reason that was not created correctly. It's a lot smaller than that 2 gigs. It also doesn't have all the directories. Again, if you were one of the unfortunate people who were unlucky and you got a USB key like the one on the right, please go see somebody up front and swap it out for a good one. And finally, actually, that's enough for now. I'll give you more instructions about the exercises later, but for now, if you could just get your USB keys going, transferring them to your computer, that would be great. All right, so with that said, let's start the program. First up, we have Michael Franklin, the director of the AMPLab, who's gonna welcome everybody and give an overview of the AMPLab and the badass stack. So here's Mike.
Nah. Okay. Oops. All right. Well, good morning, everyone, and welcome to the 5th AMP Camp that we're running. I'm Mike Franklin. As Amit said, I'm the director of the AMPLab, chair of computer science here at UC Berkeley. What I want to do this morning is just take a couple minutes to give you a little context, give you a little background on the AMPLab. The other day I was following a thread in a discussion group, and somebody online, and somebody mentioned something about the Stanford AMPLab, and so I decided, being big game week, we got to nip that one in the bud. So I want to make sure everyone understands where AMPLab is and how it got started and what we're trying to do. And then I'll tell you a little bit about the program for today. So, most of you know about us through the software we've been developing. And so obviously Spark and Apache Mesos and a bunch of other things that you'll be hearing about during the 2 days. But what we really are is a research project. Here at the university, we train a large number of really amazing graduate students and postdocs. And we actually got started in the big time as part of the White House Big Data Research Initiative that was launched in 2012. So this is just a snapshot of that announcement. The bottom line is we started the project at the beginning of 2011. We're planning to run it for 6 years, so we're a little over halfway through that. We're about 65 people if you come over to the lab and see what's going on there. So, one of the things that's unique about what we're doing in terms of an academic project is we've got a huge amount of industrial interaction and support. So, our funding comes about half from typical research funding sources like National Science Foundation and DARPA, and the other half comes from companies. A lot of you guys are from those companies, and we appreciate that. we produce a lot of software, open source. That's what we'll be focusing on over the next 2 days. But obviously, we're writing a lot of papers. All of the papers are available on the AMPLab website. So if there are any topics you hear about during the AMP Camp that you want to dig deeper on, go to the website, look for publications. If you have trouble finding anything, let one of us know. And then, obviously our students are sort of the main output of the lab. So here are the faculty that are involved. The people who run it are basically myself, Jan Stoica, who you're going to hear from next, and Mike Jordan, who's our machine learning guru. But what you can see by looking at this list is the thing that's unique about the lab is that we've taken people from a bunch of different parts of computer science, so systems, databases, machine learning, security, and got everybody to work together on a single project. And that's really one of the main keys to our success. In terms of companies, this is the current snapshot of the companies that are sponsors of the lab. The founding sponsors are the top 3, Amazon Web Services, Google, and SAP. And they're all companies that very early on made a multi-year, multi-million-dollar commitment to the lab. And, the way we work with companies, many of you know, is we have twice yearly research retreats. 3 days, we go off to, either the mountains or the coast. All the students present their work. We have a lot of deep discussions, a lot of interaction, breakout sessions, and so on. The next retreat is going to be in mid-January in Monterey at the Asilomar Conference Grounds. If you're interested in the retreats, if you're part of a sponsor company, you should talk to Kat outside. She can tell you who your representative is if you don't know. If you're not part of a sponsor company, you should talk to somebody at your company and get them to sponsor the lab. So what are we doing in the lab? Very quickly, AMP stands for the 3 resources that we're putting together to make sense of big data. So A is algorithms, machine learning, statistical methods, business intelligence types of processing. The M is machines, so we think about cluster computing, obviously elastic cloud computing and larger, data center size computers. And the P is people. And we look at people in the project in 2 different ways. One is obviously we're trying to support analysts and data scientists who are trying to make sense of data. And then the other is we're looking at crowdsourcing techniques where we can leverage human intuition and human computation to find us new data, to help us resolve ambiguities, to help us, basically solve the problems that the machines and the algorithms can't quite do yet. And really what we're trying to do is put these 3 very different types of resources together into a single system. And you'll see different parts of that, that agenda throughout the AMP Camp. So the way we look at big data is that you have a data-driven question you're trying to answer or a decision you're trying to make. And you have this 3-dimensional envelope you're trying to fit your processing into. You've got a certain amount of time that you need to get the answer. You've got a certain budget that you can spend on resources to process the data and to get the answer. And then you need a certain confidence, a certain quality coming out of the system in order to be able to make your decision. And so the challenge from a research point of view is that, as data grows and as you get more data and more diverse data, you want to try to make things go faster. And that's obviously what Spark is about. That's what Tachyon's about. A lot of the core things you're going to talk about during AMP Camp is focused on that first problem of just better efficiency, make things scale better and go faster. But as data keeps growing, at some point you're going to hit a wall. And you just can't make things go faster with the current technology. And in that case, what you need to do is start making intelligent trade-offs across these 3 dimensions, right? So, maybe if you're willing to accept an answer that's a little less confident, you can get a much faster answer, right? And so we have a project called BlinkDB that you'll be hearing about that's doing that. Or maybe you can realize that by spending a little extra money, you can bring the crowd in to help clean the data so you can get a higher quality answer. Well, that's what sample clean is about, and you'll hear that. So, our framework for all the research we're doing is really on this slide. First of all, try to make things go as fast as possible, right? So you can scale and deal with more data faster. And then second of all, figure out intelligently how to trade off time, quality, and money. And that's what you'll be hearing about, all during these 2 days. So, the challenge from our point of view is we've got these 3 very different types of resources. They're all extremely elastic. You can add them, you can take them away, you can get different ones. You've got this three-dimensional trade-off of time, quality, and cost. And of course, everyone's trying to do more and more with their data. And when you put all that together, you obviously can't use the existing systems. You need to be thinking about new approaches. And that's what we're doing in the AMPLab. So over the 6 years of the project, here's what things look like. The first 2 years, we were doing foundational work. In algorithms, we developed error estimation techniques like the bag of little bootstraps that sits in the middle of BlinkDB. Mesos and Spark came out of the very early parts of the lab. The CrowdDB prototype, which was a very early system of integrating query processing and Amazon Mechanical Turk, came out of that phase of the research. Where we are now is we're building out the platform. So you'll hear about things that we're doing to grow the scope of the machine learning that you can do with the platform. You'll hear about new parts of the system like Tachyon to do caching and make things go faster, graph processing and so on. And finally, where we're going to end up is we're basically moving up the stack, right? More sophisticated machine learning, trying to make machine learning easier to use. So use technology not only to allow you to ask more sophisticated questions, but to allow less sophisticated users to ask sophisticated questions. And that's really where we're taking the project. So sort of when I show you the stack diagram, sort of start at the bottom and move up over the course of the 6 years. So the way to think about what we're building is that if you look at the current big data ecosystem, it started off with Google MapReduce and things that were built at Amazon and Facebook and so on, and Yahoo. And the first place that most of us saw that stuff was when the open source version of MapReduce, basically Hadoop MapReduce, came out. And everybody saw that, said, hey, this is great, I can get scalable processing. But unfortunately, the thing I want to do is special, right? I want to do graphs, I want to do streaming, I want to do database queries. And so what happened is people started taking the concepts of MapReduce, right, and the idea of being able to scale out the way MapReduce does, and specialize, right? So there's special systems for doing graphs, there's special systems for doing queries, and so on. And of course, that specialization leads to a bunch of problems, right? You end up with stovepipe systems. For any one problem you want to solve, you have to cobble together a bunch of systems that were never meant to work together and so on. And so what we're doing in the AMPLab is the opposite of that. So we're saying instead of specializing MapReduce to do every different thing you want to do, let's make that platform bigger. Let's make it more general. And then if we do it the right way, we should be able to support all those different things. And so, as you're well aware, our platform here is called Spark. You'll be hearing a lot about that over the course of the 2 days. And Spark is basically an expansion of MapReduce where just by making 2 small changes, one is adding more operators so that instead of just map and reduce, you have a bunch of things you can do like joins and filters and flattening and so on, right? So you get a much richer language. And second of all, for performance, you want to be able to share the data across all those different stages of the processing, so you're not using the disk to communicate through the different phases of your program, which, of course, is going to run really slowly. So if you can make these 2 changes, which is what we did in Spark, you can build this substrate on which you can build the specialized platform. So you'll hear next about Spark SQL, which is a really fast way of doing SQL queries. You'll hear about Spark Streaming, GraphX, our ML libraries, and so on. And so, this is the approach we've taken in the AMPLab, and the results of, the stuff you're going to be using during the AMP camp is the result of that approach we've taken. So what we built is the Berkeley Data Analytics Stack, BDAS. Most of you know it's pronounced badass. And it's got the layers you'd expect. And so at the bottom, we build on Mesos, which was originally built in the lab, and then Yarn, which is a third-party system that's obviously become quite popular. At the storage layer, we use existing storage, so HDFS, S3, and so on. But we've implemented a new layer called Tachyon to make things go faster. At the processing layer, you know about Spark, you'll be using Spark. You'll also hear about a new system that we're building called Velox, which is meant, Spark is meant for sort of batch analytics. Velox is meant for serving. So if you want to do point updates to data, if you want to do point updates to machine learning models and then serve those data items and models quickly, that's what Velox is for. So, that's where the lab is heading. Spark, well, we'll talk about that in a second. In terms of different ways of getting at the data, you'll hear about most of these and you'll play with most of them during AmpCamp, but these are all the different ways of looking at the data. Look at it as graphs, treat it as a stream, treat the data as a table so you can do queries on it and so on. Run machine learning on it. Run R programs on top of it. That's what happens at this layer. And then we're driving all our work using a bunch of different applications that you'll hear about some, including some really successful and exciting work we've done in cancer genomics and some other applications. All right, so this is the badass stack, and this is really going to be the focus of AmpCamp. Some of these you might recognize in other places and maybe didn't even know they come from here. So Mesos, is of course now an Apache project. It's graduated from the lab. Spark is now a top-level Apache project. It's also graduated from the lab. And in the next talk, Jan Stoica is going to tell you about how this process of taking our open source research that we're doing here and getting it out into the world, how that's working and how we do it. Okay, but basically from a research point of view, there's a bunch of things that are out in the world and that seem to be changing the industry, and then there's a bunch of things that we're working on internally, trying to come up with the next big thing. Okay, so again, this is probably the last kind of academic talk you're going to hear. So, our main output from the lab, even though we do a lot of great software, is the amazing students that we put out. The past 2 years, we've had 8 students go into academia. A bunch of our students go into industry, of course. But they get hired at places. 3 of them got hired at MIT. 1 got hired at Stanford. They would have all gotten hired here, except we don't like to hire our own students right away. But that's what we're doing on that side. And then let me just quickly tell you what we're going to do today, and then I'll turn the mic over to Jan. This is the 5th AmpCamp. We started doing this in 2012, and we kind of alternate between doing them here and doing them at a conference like Strata. And then there's been a spin-out, which is now called Spark Camp, which is usually associated with either Strata or the Spark Summit. And the basic flow of the 2 days is this morning you're going to hear more about Badass and the components, the core components. And then you're going to do some hands-on exercises where you actually use those components to do some data analysis. After that, you'll hear about use cases, and then tonight there's a reception and an opportunity to network with the community. And then tomorrow, we're going to be more at the top of the stack. So you'll hear about some things that maybe haven't quite been released yet that are more research projects, as well as some of the advanced machine learning stuff we're doing. And then you'll get to do hands-on exercises with that, including some of the genomics software that we've been developing. So just to wrap up, AmpCamp is a huge effort. I just wanted a list. You'll see this list again tomorrow, but there's been a bunch of people who've been putting in huge amounts of time to get this thing to work as smoothly as it's worked so far. And so I just want to put their names up, including, on the right, a bunch of our students who you'll be meeting over the 2 days who are going to help with the exercises, who are taking time out from their research and classes to help out with AmpCamp. All right, and then finally, again, if you want to find out more about AMPLab, we have a great website. You can send me mail, and make sure you talk to people while you're here. And welcome to Berkeley, and thanks for coming. And now I want to introduce Jan Stoica, who's another director of the lab, who's going to tell you more about our open source activities.
Good morning. Like Mike said, I am Jan Stoica. I am a co-director of AMPLab, and currently I'm on leave, starting a company Databricks, where I am currently CEO. So in this presentation, I will talk a little bit about the community growth of the Beda stack and its impact on the industry, as well as the impact of the AMPLab. So, okay. Sorry, this is, I guess this is Yosemite. It used to be Windows. So as the software matures and becomes more and more successful, we get more and more contributors from outside AMPLab. Actually, there are new startups which were started over the past 1.5 years, which anchor some of the development of the Beda stack, Databricks, Mesosphere, and so forth. And this not only allows what we've done at AMPLab to have a great success and impact in the industry, but also it enables AMPLab to focus more of its resources on future systems, future research, instead of doing just software maintenance for the already successful components. So next I'm going to talk about a few of these successful components, and arguably the most successful one is Spark. Spark consists of a few components, and here are with dark blue in this Beda stack. And as just a bit of history, it was open source at the end of 2010. It became an Apache project last year, and over time has grown to include key libraries like Spark Streaming, Spark SQL, Machine Learning, MLlib, and Graph Computation, GraphX. So this is by supporting these libraries and targeting different workloads, Spark provides some of these unifications that Mike was talking about a little bit earlier. And as we look forward, one thing we are very excited, we are seeing more and more Spark stack becoming a platform on which big data applications are developed. So where is Spark today? Well, one way to measure that, where it is today, is by the number of commits or the number of lines of code. And if you look at the activity over the past 6 months and you compare with the other big data, significant big data projects, you can see that Spark, at least over the past 6 months, is between 2 and 3 times more active than all of these big data projects, but not only. It's also 2 to 3 times more active than MongoDB, NumPy, D3, and Julia. And Spark, it really is not only a US phenomenon, it's a it's a worldwide community. I just got this yesterday. So Spark exceeded, it has 35 meetup groups consisting of over 10,000 members in 20 cities and over 10 countries. And we are basically in all continents except Africa and South America. So you still have some work to do there. Now, another way to look, if you look in time, what is kind of the number of contributors, monthly contributors here since 2011, you see what you'd expect to see and what we like to see. It's a fast, it's accelerated growth. And especially in the past year or so, and this is not by mistake, it's also there is some correlation with the Databricks was founded in the middle of the past year, and Databricks devotes significant resources to improving and continuing the development of Spark. But in terms of community, it's again, the community is beyond AMPLab, beyond Berkeley, beyond Databricks. We have, if you look again, like the past 12 months, we have more than 370 contributors. Another way to look at the impact of companies like Databricks being created is to look at what happened with the development in the Spark stack, say, for the past 1.5 years. So this was a Spark stack, more or less, in the first part of 2013. And what happened since then? Well, Shark was our SQL component on top of Spark. So that was one thing which happened, and you are going to hear next, is that Shark has been deprecated, and a new component, Spark SQL, has been developed. And this was done at Databricks. But then there are a lot of collaboration between AMPLab and other companies. So for instance, GraphX and BlinkDB started both here, and there are now strong collaboration efforts with Databricks. And AMPLab is again one of these great successes, started just last year in the AMPLab, and now it grows in leaps and bounds. It's one, if not one of the most active components in the entire Spark stack. And here are the efforts from AMPLab, Databricks, and many other companies. New components have been created, like in the lab, like Spark R, and recently Alteryx, another company, it's allocating resources to develop Spark R, and new research projects have been started, like Velox, you are going to hear later. So it's a lot of activity going on for the past 1.5 years alone. And if you look at the wide adoption, you are also look at the enterprise adoption. And one thing to notice is that Spark, it's today distributed by all the major Hadoop distributors, including Cloudera, Hortonworks, and MapR. And one of the interesting things is that Spark, it's a computation engine. It's a processing engine, and is working not only in the Hadoop ecosystem, but it's working also over other storage systems like AWS, DataStax. As you know, they are Cassandra, commercializing Cassandra, and SAP. So we are talking about integrating Spark with HANA. And finally, companies like Databricks have been instrumental in driving Spark to enterprises. So in particular, Databricks, it's partnering with all these companies, Cloudera, Hortonworks, MapR, DataStax, and SAP, and which at the end spurred the enterprise adoption. While Spark is arguably one of the most successful components of the AMPLab stack, is not the only one, and is not actually the first one. The first component we built was was Mesos. And Mesos was open source in 2010, a few months before Spark, and it was became Apache project in 2012. It was used at Twitter for managing their clusters for the past 2.5 years, so manages tens of thousands of machines and is used by hundreds of engineers. And the most development move outside Berkeley, actually starting with 2012. And here is again another company that was created, and there is a correlation between the number of committers per month and when that company is created, and that's natural because that company allocates non-trivial resources, engineering resources, to further develop Mesos. Okay? And finally, I'm going to touch on one of the latest components of Beta Stack that, it looks that is going to be another success in the open source community. And this is Tachyon, a resource management, in-memory management system. And Tachyon, it's actually was open source only December 2012, so less than 2 years ago. And here is a growth in the number of contributions. Tachyon is not yet an Apache project, but that will change probably soon. So it's again, you see that's non-trivial number of contributors. Actually, today there are over 50 contributors. And when you look at where the contributors come from, it's again, already in Tachyon, 80% of the contributors are outside AMPLab. And recently, if you read Pivotal EMC, they announced they are going to be behind Tachyon and help promoting and developing it. So finally, if you look about, with these examples, you see that we are fortunate to create systems which had eventually a real-world impact. And we have on the right-hand side already systems like Spark and Mesos, which are used now by hundreds of companies. And on their way there, we have GraphX, which is will be part of the Spark stack, and Tachyon I just mentioned. And at the same time, you also have a deep pipeline, right? On the research side, you'll see a plethora of new systems being developed, and we hope that these systems in time will move on the right-hand side. And if you look at the resources and where this development happens, you see what, it's natural. You see what is here is what you might expect. Of course, the research is mostly done in the AMPLab. This is what happens. This is where the initial prototypes are built and so forth. But as this system become more and more popular, they have a growing community, and they get more traction into industry, you have more and more committers and developers outside Berkeley. And once they are successful, most of these committers and developers come from outside Berkeley. So what is the impact of this transition to the AMPLab? So I think it's absolutely beneficial, and there are two reasons for that. One, this transition now it creates a blueprint and ecosystem for other badass components to succeed. So for instance, AMPLab and GraphX, because they are part of the Spark distribution, which is already successful, benefit from that to get very early on a wide distribution and a wide exposure to the community. And also in terms of the blueprint, Tachyon, if you look at in terms of the process, we learn a lot about how to make Spark and Mesos, successful, create community early on, meetups, and things like that. So we learn a lot of that, and we try to improve that process, bringing a system from research to the open source community. And the second is that once you have this kind of systems being successful and having a growing community with many developers, many contributors from outside Berkeley, this enables AMPLab to increase its focus on new research projects, okay? And this is exactly what you are going to see today and tomorrow, and you are going to hear about new systems being developed, Velox, Adam, and Adam in particular. Thank you.